So today I'm gonna be solving 2402 meeting room 3. We quickly read the problem. So what I wanna to implement here is basically solution based on like two heaps. So I have n is equal to for the first example, and then the meetings 0, 10, and then 1, 5, and then 2, 7, and then 3, 4. So the first step, I'm gonna sort all the meetings by their start date. So those already sorted, like 1, 0, 1, 2, 3, 4. And then I also wanna sort if there are like two meetings that start at the same date. I wanna probably sort, I'll think later, but I wanna sort it also ascendingly. So like if I have like say 0, 10 and 0, 5, I wanna have 0, 5 in front after the sorting to be in front of the 0, 10, so something like this. Yeah, it's default property of Python sort. If the first argument matches, then the second one should be used for comparison. But what I think about right now is if it's like really the property I want to. So actually I don't care about it, as long as the room is occupied. Or it's, I don't know, it seems like in the first case there might be some inconsistencies in a room usage for the first versus for the second strategy. I'll test it later, but let's say I'll use the default Python way of sorting. So what I do first, plan first sort meetings by start date I. Second is to have two heaps. The first heap gonna let's call available, and it's gonna just store the IDs of the rooms that are available at this moment, and it's gonna be at the top of the heap gonna be the room with the lowest number, so it's gonna be gonna be sorted ascendingly. And then the second one is gonna be a busy heap, and it's gonna store current rooms that are busy, and I'm gonna store it in a format like end date, and then room ID, room I, or like room I. This is gonna be heap. Let's make it like this. And then on every iteration, I'm gonna first adjust the available rooms heap. So like I take all the busy rooms and check like from the heap pick the top element from the heap, and then check if the end date is before the current meeting start time. And if it's so, I pop the element from a busy heap and I push the room ID into available heap. And then when the process ends for every I index, I gonna take the first available room and push a new information in a busy heap. So let's say we have initially I is equal, so we have indexes for the meetings 0, 1, 2, 3. So initially I is equal 0. So I'll do okay, and available rooms are kind of 0 and 1. So I take the available equals 0 and 1, and then busy equals empty heap. So I'll take 0 room and I'll allocate first meeting into the room 0. So the busy this one gonna be crossed, and the busy heap gonna look like 10 at the end time for the first meeting, and then the room ID 0. Then I move index from 0 to 1. So I becomes 1, and I check again if I can take any rooms out of busy heap, and I check, okay, the head of the busy heap is 10, like this, the end timestamp, and the start of the current meet is 1. So it means that I cannot do that, and I check if there are any rooms available, and there are indeed 1 room available. So available was 1, and I take this room 1, and I push this information into busy heap. So I'll have this. So the new timestamp when it's gonna become available is gonna be 5 and 1, and then next one gonna be 10 and 0. Next, I move the index to 2. Then I is gonna be equal to, and then available rooms is empty. So I check what we have in a busy heap, and the earliest available timestamp is when the room gonna be free is 5. So I take this element from a heap, and basically what I do is check what the delta is 5. So I add a new kind of booking to the busy array. So a new one gonna be the former one 10 and 0, and the new one gonna be 5 here plus delta 2 minus 7, 7 minus 2 5, so it's gonna be 10, and the room 1. And then I move index to 3, and then I check, okay, I is equals 3, and then available is equal, so the timestamp is 3 start timestamp, and I check if I can take any rooms out of busy that already kind of freed up, and I cannot do that. And the available, because like both rooms gonna free up at 10, but I need them at 3. So, and the available heap gonna stay empty, and I just gonna take the first room that was there and like modify the busy, add a new booking, gonna be, so the last booking 10 and 1, and the new booking gonna be 10 plus delta gonna be 11 and then 0. So, and then I try to move the I, and I'm at the end of the way. So along with those two heaps, I gonna save the frequency of rooms usage. So it's gonna be just simple array. So it's gonna be 0, 1, and then the value is gonna be the frequencies of here. Room 1, room 0 was used here, and here it was room 1 used. And here I'm gonna use room 0, and here I'm gonna use room 1. So this is the array I'm gonna maintain, and as a result, to figure out the result, I'm gonna go through this array and figure out what the first, what's the room with the maximum, and then return it. So the maximum in this array is 2, and the first room that has like frequency of usage 2 is 0, is room 0. So I'm gonna return it as output. So the plan is the following: sort meetings by the start date I, the second one. Populate availability avail heap with rooms IDs, with room IDs. Okay, and then this room IDs. The third one, iterate over meetings, like sorted meetings. And on every iteration, I'll first adjust availability heap. So I need to check busy heap, busy heap for empty rooms. And then there's gonna be branching. If room available, use it and populate busy heap. And then here also adjust room counter. If no room is available at this time, if no room, so it's like connected, is available, then take the top, take the room from busy top, adjust end time as end time top heap, or like end time of this meeting, end time of taken meet, plus start plus end time minus start time of current meet I. And this is gonna be the new end time for the new meeting, and then like use room from busy heap, and then adjust room counter. So here I was adjusting room counter as a output, and here I was adjusting this branch, I'm also adjusting room counter. And then as the last step, like 4, go through room counter, find max frequency room, and then return room index. So what's going to be the time complexity and the space complexity of this one? So the time complexity of here, sorting is going to be, let's say we have n meetings, it's going to be log n log n, and populate availability heap, they're going to be, let's say meetings are actually, let's say call it m. So meeting is going to be m log, so sorting m log m, and heap populate availability heap. So it's just simple heapify, it's going to be O of n. And then I wanna go through all meetings. It's gonna be O of m. This adjusting availability heap. It's interesting time assessment, but in the worst case scenario, it's gonna be a heap of size n, and then the busy heap are gonna be size m, and then this one availability heap gonna be size of n. So adjusting it gonna be so taking minimum gonna be log n. But the problem is that as long as I take the minimum, I'm gonna adjust the size, so it's no longer gonna be like size n. Okay, let's do that. So it's gonna be log n, and then I need to also adjust in this case I'm gonna adjust heap, busy heap. It's gonna be log m. So something like this formula. And then here, this operation is going to be just O of n. So the time complexity for this one, I guess, is going to be something of entire time complexity. I'm going to be O of m log n log m, and here I'm going to be plus probably plus n, something like this, m log m plus n. And the space complexity, so I need to keep the heap, and I need to keep the actually the two heaps, so it's going to be O of m plus n. So let's solve that. Let's check how much time do I have. Okay, so here I have, first I will sort the meetings. Sort. Then I'm gonna have this available array, or like heap, and gonna be for I in range and gonna be I, and then I wanna do avail equals heap q heap p5, then avail, and then the busy gonna be just empty empty list, and then I'm gonna go for and then I'm gonna have this counter like usage equals 0 for I in, say, in range n. And then I'm gonna go for I in range meetings. LAN meetings. I'm gonna go like meet equals meetings I, and then first I'll adjust I'll check the busy. So while LAN busy is greater than 0 and busy is 0 and timestamp, so it can be 0 is less or equal meet start time. I'm gonna go and do avail, or like let's do a room gonna be, or like just p, or like r for record equals heap q heap pop, and then the heap busy, and then I'm gonna go and have a heap pq heap push available, and then into available I wanna push the room ID, is this one, and then I'm gonna have two branches. If LAN avail is greater than 0, I'm gonna just take the room gonna be heap q heap pop available, and then I'm gonna adjust the counter usage room gonna be +1, and then I'll push the heap pq heap push, and then busy, and then meet end time meet 1, and then room, and then else if the availability length is 0, I need to pop the busy room equals heap pq heap pop busy. This one gonna be room, and then room like end time, and then room, and then I'm gonna have this usage again for the room plus equal 1, and then heap pq heap push, so the delta gonna be, or like new end time gonna be end time plus meet 1 minus meet 0. And then I'm gonna push into busy heap this pair new end time and then room. And then in the end I'm gonna go through this usage and I'm gonna have max usage max fq room equals 0 and then max fq equals usage 0 and then for I in, let's say, room in the I in range, and I'm gonna go if max frequency is less than usage I, I'm gonna go max frequency is equal usage I, and then a max frequency room gonna be I, and then at the end I wanna return max frequency room. So this one is a solution. Let me check it. So if LAN of available, yes, it's going to be something like this. Few typos here and there. Okay, so that was my solution for this problem. Let's check what they have in editorial. This one, sorting counting using priority queues. Two priority queues, used rooms, unused rooms. Okay. That's also interesting. Okay. Okay, I'm gonna wrap up. This one solution looks like mine, and I'll probably gonna read that solution. This one is interesting, but the time complexity is like words, there is m by n component. And also my estimate for this time complexity, I was saying something like m log n log m, while they split it up. And then somehow this n log n, there is n log n component. Initializing the heap of unused rooms take n log n time in languages like C++ and Java. That's an interesting statement. So heapify is heapify will take of n. I'm sure that in C++ there is a heapify function with of n time complexity. So this one should be n, and the only mistake I got is like, should it be like plus, or like should it be here like just multiplication, so m log m log n. Okay, so that's gonna be it.